Hello, this is my screencast for week 5, my on academic language lesson plan. So the title of the lesson plan that I created is Angry Birds. And this lesson plan is adapted from something we did in a teaching class I took in my undergraduate time a couple years ago. And so it deals with quadratic equations and parabolas, and um, so a lot of what's in this is ideas I stole from a professor of mine, but a lot of it is stuff that I took to make it fit better for an Algebra 2 classroom. Um, so anyways, the standard that this applies to is construct and compare linear, quadratic, and exponential models and solve problems. Um, and the substandard is recognize situations in which one quantity changes at a constant rate per unit interval relative to another. And so again, we're going to be dealing with mostly quadratics. And to model that, we're going to be talking about Angry Birds, which fly in a quadratic pattern. And so the central focus or the literacy standard would be loosely to conduct a short research project that answers your question or solve a problem. And so basically, we're giving students a word problem, and they're going to have to read it and interpret what they're looking for in order to solve this problem, and be creative and come up with ways to solve it. So moving on, getting into the academic language section, the the verb at hand that I chose is create, and it's going to be showing up quite a bit throughout the lesson plan. But students are going to be asked to create graphs and create equations which fit situations, and also do a little bit of artistic creativity. And so, in many different senses, students will be creating. As we get into it, that'll appear more and more. Um, we're breaking down create. I said that students will use given points to find quadratic equation for each data set. Then they're going to plot a graph for each data set on the same coordinate system. Students will evaluate the graphs and determine which data sets intersect with the points of interest. And students will algebraically determine which data set intersects with the points of interest. So again, students will be creating equations from the information given in the word problem, and then using these equations to create graphs. And so rather than just giving them one to make the other, or vice versa, they're going to be creating it all on their own and then able to analyze what they've come up with. As far as language supports, for pre-learning, I said describes, table mates previous knowledge about quadratic equations and graphs. So prior to getting into this project, we're going to be kind of assessing prior knowledge and just seeing where students stand and getting them kind of leading a discourse, like getting them talking and bouncing ideas off each other, and hopefully ringing some bells from things they've learned in the past. During learning, and something that would most likely be going on fairly routinely in a class I'd be teaching. This would be just a one-day thing, but adding to a running list of vocabulary words, which jumping ahead to the vocabulary section, words such as coordinate system, which would be the XY coordinate system with a vertical and horizontal axis used to plot points with two coordinates, x-axis or horizontal axis and the y-axis, which is the vertical axis. The slope or the rate of change of a function, so how fast something is um, increasing or decreasing. The x-intercept, which is where a function crosses the x-axis or where the y coordinate would be 0. A quadratic equation, which is a function of degree 2 or the greatest exponent that an x is raised to, or whatever the variable is raised to, would be 2. And then a parabola, which is how you graphically represent a quadratic equation. So during learning, students would hopefully be keeping a list of those vocabulary words, adding it to the list that they've already kept from previous classes. And then post-learning, students read a brief summary of their understanding of the relationship between quadratic equations and their graphs. And so being able to kind of summarize and take what you've learned and regurgitate it in a way that makes sense to you in your own words. Getting to discourse. Um, so yeah, students will discuss previous knowledge, and then also students are going to be working in groups for a majority of this class period. And so in an attempt to get after the whole problem, students will all need to be able to function together, and for the teams to be most successful, they have to be able to break up the work, and they're not going to have enough time, most likely, for one person to sit down and do the whole thing, and then the other three to be sitting around. So there's going to need to be some communication and ability to work with each other. for syntax. For micro, um, talking about the general formula of the quadratic equation. So, and then being able to apply this general equation to situations. And so, but it all comes back to, um, yeah, an understanding and able to um, take this equation and apply it. For macro, would be creating graphs with model particular quadratic equations. And so, yeah, they're going to be given specific equations and then being able to determine the specific graph that fits that equation. So a little bit less general than just working with the quadratic equation in itself. Learn target again, come back to create. So the target would be I can create graphs of quadratic equations which correspond to particular sets of data. Um, and I guess the missing piece from there would be I can also create equations given data sets or equations that can model data sets. Get into the instruction. So hopefully Angry Birds is something that excites students. That's kind of the point of picking this topic, is it is kind of disguising the math as something that is fun. Not that math isn't fun, but many students may make the case that it's not something that they do um, by choice. And so trying to disguise it as something that applies to their life a little bit more and can be of interest. So as much as a teacher can kind of sell this idea of Angry Birds, use PowerPoint slides to explain the game the students don't know, that kind of thing. And then also tie in this idea to prior knowledge, tie in this, to students what they know about quadratic equations as far as just um, general form or whatever they've learned in the past. And so this is where we're going to get back into that discourse and ask students to talk with each other about what they've learned in the past, what they remember, what they don't remember, and then ultimately the teacher's going to bring the class back together and ask students to share with each other what they discussed with their partner. But then the informal assessment, teacher's going to put a review problem on the board and basically giving students 2 points and ask them to come up with a linear equation that goes to those 2 points, which hopefully by the time students are in Algebra 2, this is a problem that sounds manageable. The second half of this problem, though, would be for students to determine a quadratic equation which intersects these 2 points. And this is another huge piece of the discourse because ultimately there are multiple answers that work. There's only one linear equation that intersects these 2 points, but for a quadratic, you can come up with many. You can come up with some that are open up, you can come up with some open down, some that are very wide, some that are very narrow. But you can mess around with the data and come up with many different answers. And so hopefully through talking with those people at their table or with their partner, they're able to realize that, oh, there's multiple answers that are correct and that function as an answer in the situation, which helps us ultimately set up our problem here at hand. For the practice activity or support, this is when the teacher then introduces the problem, which is in groups of 4, students are given the Angry Birds problem, which um, essentially there's 3 pigs, which the students need to see if their birds can hit. So each pig is given a set of coordinates, and each bird is given um, a set of, excuse me, the teacher explains that the goal of the problem is to figure out if all 3 pigs, if all 3 pigs are hit by the 4 birds, and then students will be given time to figure out the quadratic equation for the flights of each of their 4 birds. Basically, there's going to be given a couple points which the birds cross through. And you'll need to give students 3 points per bird because, as we just pointed out in the formal assessment, only 2 points can lead to multiple different options. But if you give a particular bird 3 points that it crosses through, there's only one specific quadratic equation which is going to apply. It's then the student's job to figure out the equation for each bird. And once they do that, the teacher's going to bring the class back together um, and check and see, all right, so how has each group done as far as creating equations and then also graphing each equation separately on a coordinate system. The teacher also is going to ask different groups to share this equation for a particular bird. And so 4 different groups will share their 4 different equations. And they should be able to explain the process they use to come up with their equation and their graph. At this point, then, is when more of the creating will be done. They've already created their equations and their graphs, and now they're going to be able to add an art piece, which certainly I don't believe that some students are naturally good at math and some aren't, but some would certainly say they are more appealed to an artistic side of things in the classroom than just sitting down and working with numbers. And so, in an attempt to deal with that, we're going to give each group either a large poster or a large piece of butcher paper. And on the paper, create a large model of the graphs. So putting each flight of the birds, each parabola on the same coordinate system, as well as the pigs on the coordinate system in their at the coordinate pair that they were assigned. And so ultimately, this would be an easy way to show if all the pigs have been hit by the different birds. Students can add color, and then a good idea would be for the teachers to then hang up all these posters around the room after they're finished. Um, but anyways, I remember being a college student and finding this to be a very enjoyable exercise and activity, and so I'd imagine it would transfer backwards into the high school level as well. And also the math would be at a content level that would make sense for high school. As for the closure, teacher brings everybody back together and asks for some volunteers to share their final results concerning if the pigs were all hit. And then students are then asked to write a little summary of the relationship between quadratic equations and their graphs. And the teacher can collect these as sort of an exit ticket for students as they leave the class. But again, just rolling through, the vocabulary was all covered at different points early on in the instruction, and is all used throughout. Yeah, again, it all comes down to this idea of creating, and ultimately, in Bloom's taxonomy, this is, I believe, the highest of the levels, because it really engages students in just about every level of thinking, for that to understand what they're doing, and to be able to think critically and think about what's going to work best and in what they ultimately end up creating. So that's the lesson plan. Again, titled Angry Birds, and yeah, hopefully, if anybody chooses to use this in a classroom, it goes well for them.